Welcome to our session on Gen AI deployment, infrastructure, and scaling. As we build increasingly powerful generative AI models, the challenge shifts from model development to effectively deploying them at scale. This requires designing infrastructure that is not only scalable to handle fluctuating demand, but also reliable for continuous operation and delivers low latency for a responsive user experience. Getting this right is fundamental to unlocking the true potential of Gen AI in production environments. The infrastructure supporting your Gen AI models is not merely a back-end component. It is an imperative. The model itself is just the start. Without robust infrastructure, even the most sophisticated model cannot perform reliably or at scale. We face significant challenges, ensuring scalability to meet unpredictable demand, guaranteeing high reliability and minimal latency for seamless interaction, and achieving cost efficiency through optimized resource utilization. These are the pillars of successful Gen AI deployment. Architecting for scale, speed, and stability involves focusing on several key areas. First, cost optimization is crucial, demanding efficient resource utilization and proactive management to control operational expenses. Second, high availability ensures continuous uptime and resilience against failures, preventing service interruptions. Third, low latency delivery is essential to minimize response times, providing a smooth and responsive user experience. Finally, scalable compute allows for the dynamic allocation of processing power, adapting resources precisely to the workload. Scalable compute is foundational for handling variable Gen AI workloads. Cloud computing provides on-demand access to powerful GPU and CPU resources, offering flexibility. Containerization, using tools like Docker, packages models and dependencies for consistent deployment across environments. Orchestration platforms such as Kubernetes automate the deployment, scaling, and management of these containers. For event-driven or intermittent tasks, serverless functions offer a cost-effective, pay-per-use compute model that scales automatically. Achieving low-latency delivery is critical for real-time Gen AI applications. This involves leveraging GPU acceleration, utilizing powerful graphics processing units for significantly faster inference times compared to CPUs. Model optimization techniques like quantization, pruning, and distillation reduce model size and complexity without significant performance loss, further speeding up inference. Implementing caching stores frequent outputs for immediate retrieval, bypassing recomputation. Finally, edge computing deploys models closer to the end users, minimizing network latency. High availability and reliability are non-negotiable for production Gen AI systems. Redundancy involves deploying multiple instances of your model and infrastructure components across different servers or availability zones. Load balancing distributes incoming traffic evenly across these instances, preventing overload on any single point. Automated failover mechanisms detect unhealthy instances and automatically redirect traffic to healthy ones, ensuring continuous service. Comprehensive monitoring and alerting provide real-time health tracking and notify operators of potential issues before they impact users. Cost optimization is a continuous process in Gen AI deployment. Strategies include right-sizing resources, ensuring you allocate compute and memory appropriate for the workload, avoiding over-provisioning. Auto-scaling dynamically adjusts resources based on actual demand, scaling up during peak times and down during low periods. Utilizing spot instances or preemptible VMs can offer significant cost savings for fault-tolerant workloads. Regular cost analysis helps identify spending patterns and areas for further optimization. Consider a use case like a scalable chatbot platform. Cloud deployment on major providers offers the necessary on-demand scalability. Containerization with Docker and orchestration via Kubernetes enable easy deployment and scaling of chatbot instances. GPU acceleration is often crucial for fast response times, especially with complex language models. Load balancing distributes chat traffic across instances, incorporating failover for resilience. Autoscaling adjusts the number of instances based on the volume of incoming chat requests. Another use case is real-time content generation. Serverless functions can be highly cost-effective for event-driven generation tasks. Using optimized models that are smaller and faster is key to achieving low latency. CDN caching can store generated content closer to users, reducing delivery time. Load balancing distributes requests across multiple function instances or generation services. Continuous monitoring tracks performance metrics and helps identify bottlenecks in the generation pipeline. Building your Gen AI infrastructure blueprint involves several steps. First, define your requirements clearly, specifying the necessary scale, acceptable latency, and required reliability levels. Next, choose the right infrastructure components based on these requirements, selecting appropriate cloud services, compute types, and deployment patterns. Prioritize automation in deployment, scaling, monitoring, and management to reduce operational overhead. Finally, commit to continuous optimization, regularly reviewing performance and costs to refine your infrastructure for maximum efficiency.